New welcomes, working up, asking if who are about to erupt with facts like who needs debunkers, will be beaming through space while they drive their clunkers. The 4B, I'm a 4B. This investigation is legit. VFX debunkers can step off with their bull spit. Oh no. Got the name names, but what doesn't know best? In the corridor crew, well their theories are a mess. Haha, who knows where this all goes? Bless the sky and those below, but liars and deniers can suck my black hole. Y'all don't come at me, bro. Be a 4B, I'm a 4B. This investigation is legit. VFX debunkers can step off with their bull spit. Oh no.
It's H370 until you do some research. Don't talk to me. I'm going to find the truth while I sip this martini. Your opinion, it means squat to me. It's H370. Not all heroes wear capes. I wear glasses to see. I'm going to find the truth while I sip this martini. The trolls hate seeing me succeed, but guess what? H370.
Well, chat. Thank you for being here tonight, everybody. Let me fix my sound. I hope you're having a good Friday night, guys. I know I am. It's been awesome. Thank you guys for being here early in the stream. See a lot of you guys here. Happy Friday. Cheers. Cheers indeed. Please only drink responsibly and only if you are over the appropriate legal age in your location. I don't want to be promoting any, unhealthy behaviors, but it is a Friday, so we are enjoying tonight. Also, I think that a lot of you guys would probably see my last post. It looked like it was getting a lot more attention than I expected. Sometimes it's just my random thoughts posts like end up taking off, but it's important because today is Free Energy Friday. So we're going to be talking about everything related to energy. And usually that means like 0 point energy, which is the theme of today's episode. 0 point energy, 0 point fluctuations, quantum fluctuations in the vacuum, virtual particles. This is the ether. That's what we're talking about on Fridays. So thank you for being here tonight while we talk through this. Also, I'll be answering any questions in the chat while I talk about some of this stuff. The plan tonight is to talk a little bit about my most recent post regarding the resting energy of the vacuum. And it's going to lead us to talking a little bit about some teleportation stuff. And then after that, we're going to look at a scientific paper, one of the DIA papers, and then we'll see where we go from there in terms of how much time we have after that. If you haven't been following my more recent posts, like I think some of these posts have been very important. One of them we talked about on Wednesday, which was the guys talking about how physics has been kept classified from us. And if you're wondering what I'm doing, it's stuffing my olives on the side here, so I apologize. And the classified physics, I think, is essentially inertial mass reduction. So Inertial mass reduction is this idea that we can, from a local perspective of an object, could be anything. Could be, what should I do? The shaker, it was filled. To make this essentially have zero mass, how do you make that object have zero mass? And I think the answer is symmetry. So we've speculated that there's antimatter and negative energy. Matter is essentially just energy because E equals mc squared. So matter is just energy is just matter at the speed of light. So what we think we have to understand from the physics perspective, if there is this latent energy all around us, then that is essentially what represents the medium, like how the water in the ocean represents the medium of the ocean, or like how the air around us represents the medium of our atmosphere. We have to understand that there is energy that is in the space all around us all the time, and that energy can be manipulated. And when we manipulate that energy, we are manipulating the medium itself. So I think that that's really important to understand, although it's not necessarily very complicated. And so if you saw some of my replies, I think the biggest thing about this, a lot of people ask me, is, why have more people not figured this out? Why is it not publicly available? And I guess, well, first of all, just to address that one, like the people ask me, and they ask me that, and the answer is it's kind of complicated because we've basically been brainwashed. Now, for the most part, too, it's like how come other people haven't figured this out? The other answer is, well, it's been suppressed, right? People have figured this out. We are standing on the shoulders of giants with respect to this science. So, a lot of people have come before that have figured a lot of this stuff out related to zero-point energy. Some of them are still alive, some of them are not, but for the most part, very few of them have gotten the appropriate credit for what they deserve. And what we've been figuring out here is just kind of going back through what's already out there, and figuring out, just based on looking at 2 videos, that like this science that's out there is accurate. It's just, it verifies the information that we're seeing there. So from that perspective, like some people, give a lot of encouragement, but like I don't really deserve that much credit for a lot of this. It's just a matter of trying to get it out there for you guys to understand logically. So let's jump to it. First thing I'm going to do here is I'm going to pull up my post so I can talk a little bit about this for you guys. And actually, I think before we do that, we're going to watch a video. So I think sometimes the video will help us understand more easily. So I have this video queued up somewhere. Here it is. Okay. I think we're really only watch part of it. Actually, we might just watch this whole video. It's only 10 minutes long. So it starts with the Casimir effect. And I haven't seen this part about the Casimir effect yet. But I think that we need to understand, in order to understand the science of the MH370 videos, we have to understand something important. What is negative mass? What is negative matter? So people think that there's this exotic element that doesn't really exist, but it's been hypothesized, speculated, I don't know, whatever the right word is, proposed to exist by some of the great physicists. We have energy, there must be negative energy. Mass, there must be negative mass. What is it and how does it work, right? Those are the 2 things. Now, what is it and where it comes from? I've been promoting this idea of the space-time ether. That's where the energy comes from, is that we are on a flat plane of energy, right? And so then the question is, okay, if that's true, how do we extract it? How do we prove it? What would we expect the functions to be? So this first video here that we're going to watch tonight is, what does negative mass really mean? And we're going to start it at like about a minute in. So to me, the most important thing for you guys to try to understand isn't necessarily all the math. Just, depend on people like me and other people smarter than me to figure the math out. But I want you to be able to understand the concepts. And I think when you watch this video here, it's going to give you a much better understanding of why negative mass is the answer to the videos and must therefore exist. And then it's just a matter of us figuring out, okay, how do we extract it? Turns out there's a bunch of papers on that as well, guys. So this is kind of like a real life Donnie Darko movie. I don't know if you guys have seen that movie, but spoiler, like it's basically has to do with wormholes and time travel. Although not quite what we're talking about, but there's like a couple long scenes where he's talking to his physics professor, and it gets awkward where like he weirdly says something about, I can't talk about that or I would lose my job. And you're like, it's such a weird statement because it's like what physics professors should be able to talk about basically anything with their student, right? But for some reason in Donnie Darko, the physics professor is like super sketched out about talking about time travel, like thinks he could lose his job for it, which is like, huh? So anyway, recommend checking that movie out. Pretty cool. Okay, here we go. Let's watch this video. And then we're going to talk a little bit about the plane stuff, even though technically Monday is Malaysian Airlines Monday. It's just there's a lot of crossover. Oh, wait, can you guys see? What's going on here? Okay, yeah.
One common example of negative mass, or rather negative energy, is the Casimir effect,
There
a
it is.
phenomenon where two metal
So right away, guys, the Casimir effect, right? This is, if you've been watching these streams, we probably talk about the Casimir effect every single time. And that's because the Casimir effect is basically the secret sauce for proving that this stuff exists. The Casimir effect is basically the double slit experiment, but instead of for photons, it's about and quantum teleportation. It's about the negative energy states that exist within the geometry of our space-time. Here we go.
metal plates very close together block some of the quantum waves that normally fill space, especially the long wavelength ones, but even some of the shorter ones, because they require a whole number of wavelengths to fit between the plates. This creates a relative negative energy density, and thus negative pressure, that pulls them together. And this has been observed in the laboratory.
So right away, what's the answer here, guys? To pull two things together, we need to create a negative energy density pressure. And it looks like it's related to shielding certain wavelengths from that region, right? So there's some way to pull it off.
So it can happen in real life. But there are also stranger theories of physics that predict the existence of exotic matter that just has negative mass.
There we go.
But when you think about negative mass, you have to wonder, what does that actually look like?
Exactly. So if negative energy exists, then we have to presume that negative mass must also exist, right? Because E equals mc squared. So, and the beauty of this too is there's often symmetry, right? So if you have symmetry in almost everything in nature, so why wouldn't there be symmetry in mass as well? Hey, Woodragger, nice to see you. So let's watch this. And I think once we get to this part coming up here, you're going to see that you're going to understand pretty quickly why this is the answer just from watching the screen. Get ready.
The hallmark of negative mass is that in Newton's second law, F equals ma, it puts a negative sign in the equation, F equals minus ma. That means a negative mass accelerates in the opposite direction to the forces acting on it. And that seems totally incoherent. I mean, you push on an object and it comes toward you.
This has always bugged me about physics, is that for every action, there's an equal and opposite reaction. And when you're taught it, it does feel like you're being taught it dyslexic, where like he says, when you're pushing on it, it's pushing back towards you. Like, why is F equal minus ma? Why does F just not equal ma? And how come we basically just use the absolute of it when we're like doing equations in physics?
How can it do that if your hand is in the way? Almost all of the explanations of negative mass I've seen completely sidestep this question. Instead, they talk about how it works with gravity. Unlike electric charges, with gravity, like masses attract and move toward each other. If one mass is negative, we have to reverse the sign and they repel. But while positive mass is repelled from negative mass, remember that negative mass moves in the wrong direction, so it's actually attracted to the positive mass. This means that the negative mass chases the positive mass, and they both accelerate off to the speed of light.
Okay, and so here you're seeing r, I believe, is distance here as well, because yeah, it's proportionate to the square of the distance, right? So here as well, as the distance decreases, the force increases exponentially. Interesting. So, and what you just saw there was the answer in short. Now, there's going to be another example in case you just missed that just a second ago. And maybe I'll play this again just so people get it. But with gravity, the two objects converge when they're both positive. Like if it's both positive mass, then We see the curvature. This is where things collide. This is why when I drop something, it's what's really happening is that it's moving forward towards the earth when I drop that coin onto the table. Now with negative mass then and positive mass, that means it's going to be not quite the opposite, but it means as this object moves, this one's going to chase it along with it. So what does that mean? Both objects, if you have one positive, one negative, it's not going to repel like this. It's going to repel like this. It's going to follow it in a smooth motion side by side. This is very important because now we're about to show the physics of how the object moves. Hey, it's Jake in the chat. Jake, you're going to want to see this, man, because it's really important to understand negative mass and how negative mass interacts with positive mass. We're about to explain teleportation in a second here.
Since the total mass is 0, this doesn't violate conservation of energy. But this doesn't explain what would happen if you tried to pick up a solid object with negative mass.
So now here, what he just said as well is because the positive mass and the negative mass zero out in the equations, this does not, the fact that one chases the other, which it seems like it's free force, the reason why that doesn't negate, that doesn't violate it is because the mass is 0, because the mass adds up. If it counteracts one another, then you're given free energy, essentially, free force.
Now, you may be thinking solid objects aren't really solid. They're made of atoms, which are mostly empty space. And that's true, but that's not how we do physics. Normally in physics, especially if you don't understand something, you start with the simplest possible model and work up from there, like a block sitting on a table. And you occasionally see this with negative mass. Like sometimes you'll see people talk about how a negative mass resting on the ground would actually shoot clean through the earth. More on that later. But even if that's right, it still doesn't solve the problem of objects passing through each other. You never see negative mass talked about at the most basic Physics 101 level. What does that actually look like? That's what I wanted to find out through the process of making this video, to see how it would behave in situations we're familiar with.
Okay, you ready, guys?
If
So
you've
here's
taken
the key. Oops. So now you can see, first of all, the reason why I would show this video, sorry, I got a bunch of blue cheese on me, is because I want you guys to realize that like even smart people struggle with the idea of negative mass and negative energy, right? And I think a lot of people are afraid to just say they don't know what it is and they don't know how to explain it. And that's the reason why they just don't really discuss it. Then they just say, well, it can't be possible. But once you look at the effects here, you're going to go, oh, well, could this explain electrogravitics and stuff like magnetohydrodynamic engines, why there's various propulsion mechanisms related to it? Yeah, the thing about negative mass is very counterintuitive. So like when objects hit one another, if I hit the objects next to one another, we would say this is balancing out. This is going to become a net zero force. When people think of positive and negative mass interacting, they think that they're going to annihilate one another. Nothing's going to be left. But watch what happens here. Now, you've already watched The Secret, but now these demonstrations are going to help explain it for people.
Physics 101. You'll surely have learned about elastic collisions. These are collisions where, like these blocks, objects bounce off each other without losing any kinetic energy. For example, a super ball bounces almost as high as you dropped it from because it's close to being perfectly elastic. Of course, to be perfectly elastic, we have to do the experiment in a frictionless vacuum. This is the kind of approximation that physics, and especially Physics 101, is famous for. And when we do this, we don't have to worry about forces pushing and pulling, because in a perfectly elastic collision, the blocks are only in contact for an instant, 0 time. We don't have to worry about how they bounce. We can just take as a given that they conserve momentum and kinetic energy, and that they can't pass through each other. Then we can just solve for the final velocities and see what happens. This seems like the kind of toy model we can use to figure out how negative mass should behave on the simplest level. The question is, if we just plug a negative mass into the equations for an elastic collision, do we get a solution where the boxes don't pass through each other? And the answer is yes. But it's weird. Let's see what happens when we collide a small negative mass block with a larger positive mass block.
Whoa, did you see that? So it hit it, it bounced off, and the positive mass is chasing the negative mass, and the negative mass is basically reflecting back.
block. The negative block appears to bounce close to normally, but the positive block, which would normally move in the other
So you would think that the positive block would move to the right, right? You're going to hit the block here, and just like we saw in the last interaction, the block moved to the right, but instead the positive block moves towards the negative block. This is very
direction
weird.
moves backwards in the direction the negative block came from.
Also, this might explain why the plane's moving backwards. Also, holy shit. So this can also potentially explain why people wonder, why is the plane getting sucked backwards? Because that's everything's in reverse, basically, in terms of the equations and the math. Like, I'm just going to play that part just once again. I want you guys to pay attention to this. Now, once again, what we'd expect with two positive masses is that both of them would bounce apart. But instead, that's not what happens. The positive chases the negative.
Normally. But the positive block, which would normally move in the other direction, moves backwards in the direction the negative block came from.
So in summation, like this is, if you were to look at the math here, it would look like we have a net vector going to the left. In theory, when they hit one another, the sum should be 0.
If we were looking at the forces involved here, we would say that the negative block...
If you think this is amazing, now, if you're smart, what you're already paying attention to is, well, the number is 1 kilogram bouncing into 5 kilograms here. What happens if we start to manipulate the ratio of the two masses? So you saw that under this situation where a small negative mass hits the positive mass chases the negative mass. So the negative mass hits the positive mass, and then the positive mass chases the negative mass. So what if we scale that up a little bit, change the proportions, change the ratios?
If we were looking at the forces involved here, we would say that the negative block exerted a negative force on the positive block. Let's compare that result with the normal situation where both masses are positive. In the normal case, the larger block moves off to the right, but hit it with a negative mass, and it moves to the left. And note that I can reverse the signs on all the masses and still get the same result. Negative on negative behaves exactly...
Yeah, so negative on negative, it behaves the same way as positive on positive. So it's almost like it doesn't matter what if our matter and our energy isn't positive or negative. It's just the opposite of the other type of energy that's out there. So at the end of the day, they're both the same thing. They're just, I don't know if you want to consider it polarized different ways. But this is why, like, negative energy isn't like some purple mist, right? It's just the same stuff. It's just the opposite. Because there's symmetry in everything. Positive. Even in space-time, there's symmetry.
It's opposite masses that give weird results. But it is a weird result, and it's not obvious why the blocks are moving this way, even though that's what the equations say. To see what's really going on, it's easier to look at a slightly different problem. A perfectly inelastic collision happens when two objects collide and lose the maximum possible amount of kinetic energy, which happens when they stick together. When one block hits a second with the same mass, for example, they stick together and move forward at half the speed, because the combined mass is twice as great, and momentum has to be conserved.
Yeah, so inelastic collision is basically they just stick together and move as opposed to constant apart.
Let's see what happens in an inelastic collision where one of the blocks has a negative mass. We still aren't worrying about forces at this point.
So, guys, did you just catch what you just saw right there on your screen? So, if it's an inelastic collision, that means that the first mass hits the second mass and keeps going. What's the difference between positive and positive negative? And the answer is, in the positive negative, it moves much faster. So in an elastic collision, it hits it, boom. But because there's this excess energy that we see from the negative interaction, we're now getting that vector travel, this way, and it's moving faster than it was initially. So I'm coming in at speed 1, boom, hit my object, and I move even faster, speed 2 now. So there's free acceleration that's happening here. There's a force happening.
We're just assuming that the blocks can stick together without any trouble. In this setup, when the big block hits a positive mass target, it slows down. But when it hits a negative mass target, it speeds up. Why?
Sorry, say that one more time. When it hits a positive mass target, it slows down. When the positive mass hits a negative mass, it speeds up. That's what the math says. That's what the physics say. That's the answer. That's what the Casimir force is doing, right? And this shows us that we can actually manipulate, call it, maybe it's the polarization of the vacuum of the energy states. And if you manipulate the energy states or the mass here with one of these types of interactions, you're going to get anti-gravity. That's what anti-gravity is, what you're looking at right here in the bottom screen. Get ready for it.
Because the combined mass is smaller than the big block alone. So
Look
for
at that.
momentum to be conserved, it has to move faster.
In order to conserve
the two
momentum and to be accurate to the physics, it has to move faster. Just doing the math.
Masses are close to being equal.
Now look at this. So these masses are much closer to equal now, okay? So what's going to happen with the first one? It's going to slow down relative to how fast it was moving before, right? So if a large mass hits a small mass, it's going to move pretty fast, right? But if it's a big mass that you run into, it's going to slow down a lot more. What do you think is going to happen when we do the opposite? When we have a bigger mass hitting negative mass, hitting the positive mass.
Equal and opposite, the
It's
combined
going to speed up, right? Get ready.
mass is very small, and they move very fast.
Look at that. Look at that difference. So when it's positive, and they're close to the same amount of mass, it moves extremely slowly in a collision like this. When it's positive, negative, and they're nearly the same mass, it's moving at super speed. So yeah, speed up. Now, what do you think happens, Jake, when they're both exactly the same amount of mass, but one's positive and one's negative?
And if they're exactly equal and opposite,
Boom! Instantly gone. You're dividing by the mass. So if the masses exactly equal each other out, now you have zero net mass. What is zero net mass? That's mass reduction. That's inertial mass reduction. That's what Salvatore Pais' patent is, inertial mass reduction. Why is inertial mass reduction so important? Because if you get to zero, you're teleporting.
move faster. And if they're exactly equal and opposite,
Instantly gone. That's teleportation right there for you. And what does the guy show? He shows a picture of the atomic bomb going off, right? Because this is where we learned E equals mc squared. The atomic bomb is when we figured this out. I think we've been hiding this since the 40s, since the Manhattan Project. That's about, I think, like almost 100 years ago they figured this out. And they've been hiding that half of it this whole time. So, yes, then the question becomes, how do you get negative mass, though? Does he talk about it here? I don't remember. We'll probably watch through the end of it. It's only a couple more minutes, but I want to watch that one more time because that was the kicker for me. And I was watching this video earlier because I was looking for this because I knew this physics is how it worked. I remember watching a video earlier, but I didn't really think it through. And once I realized, oh, if the masses are exactly equivalent, now you're going to have basically teleportation, quantum entanglement, quantum teleportation. I don't know, whatever you want to call it.
and if they're exactly equal and opposite,
Boom. Infinite speed. That's what this equation right there shows, right? Dividing by zero, what's the answer? That means velocity is infinite. What is infinite speed? Speed of light. Maybe faster than the speed of light. Teleportation. Absolutely wild. That's the math, guys. The math is so simple. It's just F equals ma. So the velocity of the force, the velocity or the force equals the mass divided by, or sorry, the acceleration equals the mass divided by the force, or the acceleration equals force divided by the mass. Sorry, mass is on the bottom. Pretty wild. So let's finish the rest of this up. Because then we're going to talk about how do we extract it.
so that's a bad sign. If the physics starts throwing divide by zero errors, there's a good chance you're doing something wrong. But hey, this is just a toy model. And for macroscopic objects, the masses are never going to cancel exactly. So let's keep going. You actually get...
For macroscopic objects, the masses aren't going to match exactly. What if they did? What if they did? So here's the answer. That's what I wanted to show you guys, because now when we watch these videos and I think we'll probably finish the rest of it too, just in case. I don't remember if there's more. What are the orbs doing here, guys? So what are the orbs doing? We know what the orbs are doing now. That's all we had to know from a scientific perspective to know exactly what these orbs are doing. They aren't measuring the length and the width of the plane. They're measuring the mass of the plane, right? That's what these orbs are doing. They're measuring the mass. They want to know what is the mass of the plane and all the occupants, because they don't know. There's 239 people on this plane. There's cargo on this plane. So you can't know the mass just from knowing the weight of the airplane itself. You have to know what's in there right now. Why? Why are you mapping it? Because you need to create an exact opposite negative energy state or negative mass. It's got to be exactly the opposite. And once you have exactly the opposite, just what we saw from the ratios, poof, your plane can now accelerate at the speed of light. And then the problem is, okay, well, you can teleport at the speed of light. You can move at the speed of light. We've broken the equations. We talked about magic cards and making a magic card deck. What are you trying to do when you make a magic card deck? You're trying to break the rules. That's what you're trying to do. So what we're trying to do here is we're trying to break the rules. So what we need to be able to do is we need to create a shell around our plane so that we displace our plane from space-time. We need to create a wormhole. We need to bubble through it. And how do we do that? We break the Schwinger limit. The Schwinger limit is the energy density limit of the space area, the space-time area, that causes that area to become nonlinear. Nonlinear, you can imagine, is just ripping a hole through the reality that's there, through the energy state, the natural energy state that's there. So it's funny because, yeah, people are talking about CERN. Well, this is why people were freaked out about CERN. This is why physicists were talking about CERN creating miniature black holes. Because theoretically, with particle accelerators, you can pull these types of effects off. I think the reality is the orbs that we see in the MH370 videos are well beyond what CERN is doing. This is like everybody's nightmare for CERN. Because if you can do this and you can teleport an object, you can create a black hole, you can annihilate the plane. Like, this could still be annihilation. We think it's teleportation, but if you can create negative mass, then you can theoretically cause, once you cause both sides to become zero, right? 5 minus 5 is 0. Now you have situations where the equations show infinite. And what does infinite mean? Or 0, right? So negative mass, once in one of the papers that we looked at, I think it's one of the Eric W. Davis papers, he talks about the mass energy it required to create a wormhole. Why does he talk about the mass energy? Because he's saying that basically mass and energy are interchangeable. Mass is energy. So they might not even have to make the mass. They just have to make the amount of energy equivalent to that amount of mass. So, or negative energy. And how are they getting that? Well, I guess that's the question on what is negative energy. And once we know what it is, then we can figure out how to extract it. And if we are seeing negative energy when we see these interactions here, this is technically negative energy and harnessing negative energy. How are we able to pull off the negative mass? How are we able to manipulate this effect? And the answer is we manipulate the medium. We have to manipulate the medium. So we have, imagine we have this area you see on the screen is all space-time. If I cut off this half of it, then all the rest of it has to fit into this half over here, right? And now you can imagine that's manipulating the total amount of energy. You're taking the energy out of this area and you're pushing it over here into this area. And that's going to manipulate the thermodynamics. You're squeezing it together. You're either expanding space or you're contracting it down. And if we manipulate the energy densities in this area, then we can cause gravity to be manipulated. We can bend space-time like a piece of paper. Pretty wild. So let's finish watching the rest of this video. Funny part is, I think all physicists would agree. I think the problem they would say is, well, how do we get the negative energy? I think the answer is you just manipulate the vacuum.
Get pretty similar results from elastic collisions. Even though they don't stick, the fact that the combined mass is smaller than the big block means that the big block can speed up and still conserve momentum. The collision transfers a negative amount of momentum to the negative block, leaving the positive block with more. Turn it around so that the small block is moving, and we have our original weird result. The negative block transfers its negative momentum to the positive block, negative meaning pointing to the left. Since it also has to bounce off, it winds up with
So we can go in two different directions here, right? We can either go forward or we can go backwards. I mean, that's what the simplest math basically shows us. You cancel it out, and one option, you're going to continue going forward. If it's the positive block hitting the negative, if it's the negative block hitting the positive, then it's going to go backwards. So I guess that tells us the orbs are potentially negatively charged, and the plane itself is positive. But it might, yeah. I guess that's what
positive
that tells us,
momentum,
right?
and with its negative mass, moves to the left faster than the positive block. Now, what about that shooting through the Earth problem I mentioned?
Yeah, honestly, the second example you just showed there, to me, is what we're seeing with the plane.
More.
We're having our negative charge down here hit the positively charged plane, and then the plane is going to go backwards. And then I guess this would be like the orbs getting pulled towards the fourth orb, maybe?
Turn it around so that the small block is moving, and we have our original weird result. The negative block transfers its negative momentum to the positive block.
That feels like
Negative
that's the
meaning
answer.
pointing to the left. Since it also has to bounce off,
We don't see an orb in the video, but of course we don't, because the area we're seeing in the MH370 video is a very small area. You know, this plane's probably getting teleported thousands of miles.
it winds up with positive momentum, and with its negative mass, moves to the left faster than the positive block. Now, what about that shooting through the Earth problem I mentioned? This is related to the original your hand is in the way problem.
I don't think we care about this part, actually. I think that was good. Actually, let's watch it. It's only 2 minutes.
A normal block doesn't fall through the ground because the ground is pushing up on it. That's called the normal force. And in fact, by Newton's third law, there are two of them. The ground pushing on the block and the block pushing on the ground.
To answer this question, are they so are all the orbs positive or negative charged? That's a good question. Honestly, I don't know the answer to that. Then maybe that like a couple of them are like one of them is positively charged, maybe. Not really sure. That's a good question. I think it's so long as the net charge is negative, then you're going to have this interaction that you see in general. But it could also just be that the fourth orb is negatively charged. I'm not sure. Good question. Oh, sorry. Here we go.
How does that work with negative mass? It seems like it would make the block accelerate down through the Earth.
It's going to go up.
But I'm not so sure. We can get some clues here by looking at walls. In Physics 101, we can just treat a wall as an object with infinite mass so it can't move. And it turns out that if you collide a negative mass block with a much larger target, it behaves more similarly to a positive one. And if you use an immovable wall,
they move exactly the same.
They're identical. Why should this be? Shouldn't the wall exert a leftward force on the block, making it accelerate to the right through the wall? Well, remember that with the elastic collisions, the negative block can actually exert a negative force, which maybe even makes sense since, it has negative mass. It's not clear how a push could be a negative force. After all, the equations for an elastic collision don't mention forces at all. But conservation of energy says it works. So, if the negative block pushes the wall with a negative, that is, leftward force at the moment of impact, the wall would exert a rightward force on the block in return, causing it to move to the left. By analogy, we can make a hypothesis that a negative block can rest on the ground just the same as a positive one, if the normal forces are also negative. Are they negative? Normal forces aren't magic. They're caused by electrons, but we'll need to work up to that level. Remember, all of this is the Physics 101 version. It's a toy model, and as we say in physics, all models are wrong. Some models are useful.
So what he was getting at there is that maybe the negative mass would cause an object to move up, basically anti-gravity, essentially. But I think the bigger thing is if you can have your mass become zero, now you're going to float freely based on looking at the equations here. Just hovering, no force, just hover. If you can have if you can exactly zero out the positive and negative energies and or positive and negative masses. Pretty interesting. It's kind of weird that if you were going to a wall of infinite mass, though, they both act the same on an inelastic collision. They both bounce off. Yeah, so one of the things, though, is that from a relativistic perspective, the plane's not actually achieving light speed. That's the thing. That's the rub that makes it hard to quite grasp, is that the area around the plane is, but the plane itself is just going to appear like going through a doorway. And that's the part where it gets kind of weird, because once you get to zero mass, now you can have an object move like we just saw instantaneously. And what's the instantaneous transmission like we just saw? Instantaneous transmission is equivalent to ER equals EPR in quantum entanglement. So quantum entanglement, we see particles that are zero mass particles, or infinitesimally small, let's say, and they are able to move at the speed of light with quantum entanglement, quantum teleportation, because they have no mass. So if we take something very large, or however large you want it to be, like the martini glass here, and you reduce its mass to zero by hitting it with the exact opposite negative mass, now this object can float freely. Now I can push it and it's going to go to the speed of light instantly. This is, if we can do it with quantum mechanics at zero mass, why can't we do it with some other object that we change to zero mass? The answer is, according to the math, we can. According to the math, we can. So this shows that the math will work out for us to be able to approach infinite relativistic speeds just using F equals ma. That's it. That's all we need. So how do we extract the energy then? That's the next question, right? And I'm not going to pretend like I know for sure all of these answers. I'm just showing you the basic math here. Also, let me fix my camera real quick. One sec, chat. Sunday morning. I'm going to dox myself here, but I was just listening to Gwen Stefani outside. Oh, now I'm too high up, though. That's good enough. Okay. So let's take a look at this DIA paper here. Because now that we understand like what we have to do. So in order to teleport an object, we need to manipulate the energy state of the medium. Now the medium is not empty, okay? So everything around us, this whole medium of this screen is filled with negative energy everywhere, right? Same as the quantum vacuum. We call it the 0 point energy. Even when we get to the ground state of absolute zero, there's still energy there. So there is energy out there. We know it's out there. Let me remove this. So then the question is, okay, how do we create a negative energy state, assuming that the Casimir plates are able to create a negative energy pressure zone? So if the area between two plates creates this negative energy pressure, we can have our plates move together. So if we take 1/2 of our energy state and we remove that energy state, there's going to be a force that's going to happen. You know, potentially we're going to have a situation where we're manipulating the geometry of the vacuum. Right? We're creating a suction. We're creating a little black hole there, so to speak, of negative energy. And if we can do that, if we can pull away all the area around there, we can potentially access negative energy. We can potentially, the other way I would look at it is this, is like cold fusion. What is cold fusion? What is the sun doing when we see it out there? How is cold fusion able to create over unity? The energy must be coming from somewhere. So with the tokamaks or whatever, they all say they put in a certain amount of energy and they're getting out 300% energy. That's, the sun is doing that too all the time. When that big star we see out there, how is it pulling it off? Well, it's pulling that energy from somewhere. Where's it pulling it from? Probably the quantum vacuum, the space-time ether, from that energy state that's all around us all the time. It's sucking that energy in, radiating it outwards towards us. So we can turn that energy, that's potential energy, out there in the vacuum into actual workable kinetic energy. Turn it into kinetic energy, and now we can turn it into electricity. Now we can power things with that. So that's the concept behind 0 point energy. So 0 point energy is that energy that's all around us all the time. We know it's real because the Casimir effect shows us that it's real. We know how it's going to interact because now we just watched that video that showed negative mass and how it would interact. So if we change the pressure zone, negative energy pressure zone of this area on my right hand compared to the side on my left, we're going to see a force one way or the other. We know that now because that's what the experiment we just watched showed us. So it's not just going to cancel out. It's not going to become zero. There's going to be some type of movement of all the energy state around. So now let's try to figure out how we could actually use that as actual workable energy. Yeah, hydrogen's fusing and turning into helium. And that's kind of how we've been explained that stars work. Fundamentally, I think that's how they work. But like, how is it really, where's that energy actually coming from? Right? Oh, we're just breaking apart the bonds and stealing that energy. But E equals MC squared. It feels like there's too much energy coming out relative to how much is being utilized. That's why the sun lasts for so long, billions and billions of years, instead of burning out very quickly. At least in my opinion. I think it's just at least one factor, let's say. Hold on as long as you want, man. I feel extremely confident that in the near future, this will get proven to be true. I mean, the physics is already true. It can't be argued. It's the math is there. We just looked at an example of it. The real question is, can we extract the energy and can we produce the energy? I think that's what would be more controversial than what we just showed. Let's see if I can change this. Okay, should be good. But so then that begs the question, though, right? In terms of what is ER equals EPR? Einstein-Rosen, which is a wormhole, versus Einstein-Podolsky-Rosen, which is quantum entanglement. So why does quantum entanglement, quantum teleportation, why does it exist? Why is that even a thing? Like, why is spooky action at a distance even work? How are we getting relatively faster than light transfer of energy? How is that possible? And I think now we know the answer is based on those equations. You create an infinite scenario, and the infinite scenario means it's moving faster than the speed of light. And so why can we not do that for a wormhole? Based on the math that we just saw there, we can. Yeah, I could explain out-of-body experiences. I think that one thing that I thought about with respect to some of the esoteric aspects is, can this explain stuff like remote viewing? Can this explain, out-of-body experiences? Can it help explain the soul and, where we come from and what have you? I think that it probably can, because you can scale up all the same equations at the macroscopic scale, the microscopic scale to the macroscopic scale. Yeah, and I think a lot of people would say, and I agree, everything is connected to everything else via invisible dimensions based on infinite energy making up all of creation. Yeah, some people asked in the chat earlier, like, where does this come from in general? And what I think of when I think of this as music, I think of two music notes hitting each other and creating the universe, like in a Big Bang type situation. The moment you find some asymmetry, now complexity becomes possible. And then it's just a matter of adding the time dimension to it. Billions of years, trillions of years, infinite amount of years. And the complexity is going to keep increasing over time. Entropy. When everything's in harmony, you're not going to have that happen. Like a musical note that's just floating. But the moment you have a disturbance and there's an asymmetry, now you have the universe. So where do we come from? We come from some, I would say, infinite amount of energy that was probably flowing in harmony until one day that energy created an asymmetry, either through a collision or a random chance or whatever you want to call it. Maybe creation, maybe divine creation. And then all complexity began. And that's what's been going on ever since, for however long, maybe forever. This is why I asked the question earlier about how old do you think the universe is? Because if you believe that energy, everything is connected, that distance is an illusion and all energy is connected on a dimension that we don't perceive, in some way, then the big question is, where did that come from and how long has it been out there? Pretty interesting. Yeah, and this helps explain why did the government spend so much money on remote viewing and some of these concepts? Probably because they knew that the space and time are an illusion, and that if everything's connected, then there's some merit to the idea that remote viewing could be possible, and some of the other more esoteric things, even phenomenon like ghosts and things moving around when they shouldn't. I think all of that stuff can be explained theoretically. Yeah, the more and more I look at this, the less I believe in the Big Bang Theory, although I still think there's some kind of creation that must have occurred. Okay. Now, this paper here, I think that this one, like I posted all the papers, the list of all the papers on my YouTube channel or my Twitter channel probably like 3 weeks ago. And I believe this one was written by Eric Davis, which is important because he also wrote the teleportation physics study, which we're going to look at a little bit of that if we have time here as well. That'll be the next thing we'll look at. Actually, I kind of want to look at the teleportation physics study first, and then I want to go back to this. So let me find that. It's right down here somewhere. Here it is. Pull this up. Oh, okay. I got to switch my screen share. Hold on. Okay, so this is the teleportation physics study. And I believe the last one that I was showing just a second ago, this one right here, extracting energy from the quantum vacuum. I think both of these were written by Eric Davis. So, like, I don't know. I've never met Eric Davis or even talked to him, but this guy knows some stuff, man. I mean, how do you not? How do you not? It actually blows my mind that more people don't realize, like, this guy's got to be, like, on the upper echelon of people that have control of this technology. If he's not, like, he knows all the right people. I mean, Air Force Research Laboratory. Like, why was the Air Force in 2004 commissioning a teleportation physics study? Like, just wrap your mind around that, right? They weren't like commissioning a study about demons, right? They weren't commissioning a study about ghosts. No, they're like, give us a physics study on teleportation in 2004, 2003 even here. Well, the answer is because they know this stuff's possible, or they at least must have highly suspected it, right? I don't think Eric Davis really does a lot of interviews. He might do some, but he probably isn't going to interview with me, which is fine because I got more than enough information here. And so just looking at the table of contents, because we can't go through all of this, engineering the space-time metric, VM teleportation. This is the kind of teleportation that we're talking about, moving an object through a wormhole. And what does he talk about? He talks about engineering the space-time metric. What does that mean? Well, I just explained it to you guys. This area is the space-time metric. If we're manipulating the energy states in the space-time metric, we're manipulating the medium. We're manipulating gravity. Now, the reason why we don't call it anti-gravity is because we're making our own gravity based on manipulating the space-time metric. That's how gravity must be. Gravity must be the natural interaction in the space-time metric based on mass displacing negative mass or something equivalent of that. So if that's the case, then the whole answer is manipulating the medium. That's what we have to do. Then he talks about using a thin shell wormhole, that's going to be able to create what you need for teleportation. I mean, this is exactly what we're talking about. And then exotic energy matter requirements. And in page 11, I think this is the one where on page 11, he talks about, there's the Casimir force right there, by the way, Casimir effect. And page 11, energy matter requirements. He generally talks about energy and mass interchangeably. I think he's the one that talked about energy mass requirements. I don't see it there, surprisingly. But I think somewhere in this paper, oh, there it is right here, mass energy. Now we have to estimate the negative amount of mass energy that will be needed to generate and hold open a VM teleportation wormhole. Like, now that we've seen that video, oh, sorry, I didn't have this. I wasn't sharing screen. Right here. So the exotic matter energy requirements. So Eric Davis literally, obviously he understands what we were just showing on that video, right? He understands that video because he's going, okay, now that we have this theoretical concept for infinite speed, negative energy equaling to negative mass, how do we get negative energy and negative mass? And what is it? And how much do we need? So he shows the math here on what we need to be able to pull it off. And I still have to learn about some of this in general, but M here is the mass. And then G must be the distance. Or maybe it's just gravity. I don't know. I don't think big G is gravity. I think the little g is. Either way, if we make our shell, but anyway, what he says here is Visser in 2003 demonstrated the existence of space-time geometries containing traversable wormholes that are supported by arbitrarily small quantities of exotic matter energy, aka negative energy. And they proved that this was a general result. So basically, they're saying people have already figured out ways where we can do this with just very small amounts of energy to create a shell, a wormhole, basically, so that we don't need this giant amount. Now, the thing I wanted to show you guys, if I go up there, but yeah, there's the math right there, if people care. Page 60, somewhere around here. Okay. P teleportation. So for my remote viewers, let's take a look at what the examples of the types of teleportation are. He's got the definitions here before we go to page 60. P teleportation, psychic teleportation, the conveyance of persons or inanimate objects by psychic means. We call this P teleportation. So here he's talking about remote viewing, right? That's what remote viewing is. So using psychic conveyance. So basically he's saying that one of the ways that teleportation could be possible is not just a wormhole, but like literally like some type of astral projection or remote viewing capabilities. That's what he's talking about right here for P teleportation. And we're about to go read something from it, so get ready. But my favorite, of course, is VM teleportation, which is engineering the space-time vacuum. And now this, again, is like taking your turkey baster. The VM teleportation is like taking your turkey baster, squeezing the space-time vacuum. Remember, what's going to happen? You're going to get a pinch effect. You're going to get your object fly away at super high speeds. You either pinch or you expand space-time, depending on what you're trying to do, what direction you're trying to go. And I think Q teleportation was, quantum. Yeah, quantum entanglement. Q is quantum entanglement. VM is a wormhole. P is your remote viewing, your psychic. And then sci-fi, which is the disembodiment of a person or inanimate object by advanced technical means. They call this sci-fi teleportation. So sci-fi teleportation is not real, guys. Where you get disembodied atom by atom and then put together atom by atom. That's not real teleportation. And this is why people get confused. The sci-fi teleportation is fake. Psychic teleportation probably got the least amount of likelihood, but still is theoretically possible. But these other ones are almost certainly real. So VM teleportation is a wormhole. Q teleportation is quantum entanglement and quantum teleportation of information. And then exotic, E, is conveyance of persons or inanimate objects by transport through extra dimensions or parallel universes. So this is the idea that we have multiple universes are interacting, and you might be able to jump between one and the other. So this would be like your Mandela effect down here. Pretty weird, huh? Okay, so let's go take a look at P teleportation. And the other thing, too, that why are we talking about teleportation on 0 Point Energy Day? Because teleportation is related to manipulating the 0 Point energy vacuum. Because the energy vacuum is the medium. That's what space-time is. It's just a medium of energy. And we manipulate that medium, and theoretically, we can extract the energy directly from the medium. If we pull energy, let's say we pull energy out of an area. We pull energy out of here. What's going to happen? It's going to get colder. You're pulling the energy out of it. It's going to get colder. So if you're extracting energy, then you are essentially making that area have negative entropy. It's getting cooler. And where's that energy going? It's coming into my system over here. So I've opened my system up to this area, and I'm going to pull this energy into my system over here. Okay, where's 60? I think that's why the local energy state gets colder, is they're extracting that energy from the environment. And they're either pinching space-time together or they're expanding it. Okay, here we go. Hypothesis made based on mathematical geometry. So basically they're saying, how can psychic teleportation even be a thing? You know, isn't everything super far apart? So I think if Jake's in the chat, I'll probably enjoy this. Chinese researchers reported in their teleportation experiments that high-speed photography / videotaping recorded test specimens physically melding or blending with the walls of sealed containers. And in a different series of experiments, the test specimens would simply disappear from inside the container, only to reappear at another location after seconds or several minutes of time. They also reported in a series of radio microtransmitter experiments that there were large fluctuations in the intensity, both amplitude and frequency, of the monitored signal to the effect that it would either completely disappear or become extremely weak, to the extent that monitoring instruments that could scarcely detect it. And they discovered that there was a definite correlation between the change in strength, radical frequency shifts were observed, of the monitored radio signal and the teleportation of the radio microtransmitter, such that the weak or absent signal indicated that the specimen was non-existent or in an alternate physical state during the teleportation. This data is important because without the aid of electronic monitoring instruments, the average person's sensory organs and usual methods of detection are temporarily unable to perceive the test specimen's ambiguous existence during the teleportation process. This data offers an important clue on what the teleportation mechanism is. Yeah, is that pretty damn weird? Oh, again, I wasn't even showing it, but I just read it to you guys. So I'll put this back up here again. I'll reread the significant parts. So the biggest part to me is this last part, where the data is important because without the aid of electronic monitoring instruments, average person's sensory organs and usual methods of detection are temporarily unable to perceive the test specimen's existence. So it is almost like just shielding the specimen, shielding you from everything that allows somebody to sense you, and you're just not there anymore, right? It's like making an invisibility cloak. But this invisibility cloak allows you to be from over here to over here instantly, which is what we know as teleportation, right? It is beyond the scope of this study to propose a complete self-consistent physics theory of consciousness and mind, which explains how mind can activate psychic teleportation and related psychotronics phenomenon. This topic has been under study in recent decades by a legion of medical science, bio and neurophysiology, psychology, mathematics, physiology, or philosophy, and physics experts. Many of the theories with varying degree of theoretical maturity and self-consistency have been proposed over the years, and most of them have not yet been experimentally tested for various reasons. However, some first-order experimental work has been done by Mitchell, Targan, Puthoff, Woolman, Marco Radin, Tart. Ironically, quantum mechanics theory and the related physics of quantum entanglement and teleportation have become the primary focus of all the physics theories of consciousness and psychotronics that have been recently proposed. So basically, every single method of consciousness projection and psychotronics has been based on teleportation, essentially. I think for Jake, he already expected that. Thank you very much for the donation, Gray Scout. Is 0 point energy possible? Is possible? What is the need for a Dyson sphere? There is no need. I think this is the answer for why we're not seeing Dyson spheres. It always bugged me that we didn't see Dyson spheres in the sky, that there must be civilizations everywhere. So where are the Dyson spheres? Why are people not building things that extract the energy from the sun? The answer is actually simple. Why don't we see them? They don't exist. Why do they not exist? Because they're not needed. Because it must not be the most efficient way of extracting energy. The only reason why we think it's the most efficient way is because we are not currently in mainstream doesn't believe that 0 point energy is possible. If you can extract energy from this area here all the time, and there's enough energy to power your home for all of existence, then why do we need solar power? We don't. This is why I call climate change a scam. Because solar power and wind power are not green. They're not green power. We just imagine they're green. There are negative externalities related to those energy systems. For solar, it's a matter of it's not very efficient and the panels basically won't biodegrade. So we're just making junk essentially that have to be replaced. And if any wind damages it or any hail damages it, they got to be replaced. And they don't work when it's not sunny. So there's a host of problems related to them. With wind power, we're just killing birds. You guys have seen it. And they, in terms of like if they get damaged or ever smoke, they're extremely bad for the environment. So all of these things are just, they're spreading pollution just in different ways. 0 point energy is the answer to all those things. So this is why we don't see Dyson spheres. Okay. Ironically, quantum mechanics theory and the related physics of quantum entanglement and teleportation, oh, sorry, I already said this, have become the main theories. Okay. Woolman and Radin provided a review and discussion on recent theories and experiments that are based on quantum physics theory. So this was back in the 70s through the 90s. So the other thing here that's really important is we can get a good concept of how teleportation is advanced over the years. So they were already talking about these concepts in the 70s, 80s, and 90s. And now we're in 2024. It appears that the physics of quantum teleportation, has tremendous relevance to the physics of P teleportation. So right here, Jake, this is... You probably want to talk to Eric Davis when anybody gets a chance, because Eric Davis is connecting quantum teleportation. Q teleportation is quantum entanglement. So they're connecting quantum entanglement right here to remote viewing. In the following, I proposed, parsimonious first order hypothesis that can explain the gross features of both Chinese P teleportation data and the other reported P teleportation phenomenon. Okay, yeah, this is a good example here. I think this example is good. We're going to see. So I think this helps to visualize it. The mature discipline of mathematical geometry developed the properties of higher dimensional spaces. An example of one such property is of relevance to the hypothesis. One can visualize a 4-dimensional world by using color as the 4th dimension. We can think of the 3-dimensional world whereby objects pass through one another if their colors, the 4th dimension, are different. So if your colors are different in the 4th dimension, they pass through one another. But if they're the same, they're not going to. For example, color can be used as the 4th dimension to see how a knot in a 3 dimensions can be untied in the 4th spatial dimension without moving the ends of the cord. This is because a cord cannot stay knotted in 4-dimensional space because the extra degree of freedom will cause any knot to slip through itself. 2 other interesting and relevant examples that are links in a keychain may be separated and unbroken in the 4th dimension, and a flexible sphere may be turned inside out without tearing in the 4th dimension. So these 4-dimensional understandings are basically things that we would think of are impossible. So he gives the example like if you were to tie a knot in the 4th dimension, you would pull on both sides of the string and the knot would just become undone. It seems impossible in 3-dimensional space, but in 4-dimensional space, it is possible. Or flipping a circle or a sphere, right? If I have a sphere, I wouldn't be able to invert it. I have to rip it in order to invert it. But in the 4th dimension, we don't need that. So this is like the extra dimensional properties of like the dimension that we don't see, the space-time ether potentially. Yeah, you could also bend your spoon. That's what Uri Geller was relatively famous for, right? What document? This is the Teleportation Physics Study. Teleportation Physics Study by Eric Davis. You can find it if you just Google it. Pretty simple. Excuse me. Okay. I think we're going to stop there with that. Let's go to the conclusion, actually, on this. Therefore, the results of the Chinese P teleportation experiments can simply be explained as human consciousness phenomena that somehow acts or moves or rotate test specimens through a 4th spatial dimension, so that the specimens are able to penetrate the solid walls and barriers of their containers without physically breaching them. No real dematerialization or rematerialization of the specimens takes place. the intensity fluctuations of the radio microtransmitter specimen's electromagnetic signal and the apparent blending of the other specimens with the walls of their containers represent the passage of the specimens through a forced spatial dimension. So what he's saying here is the reason why in the Philadelphia experiment people got stuck in the walls is because you're moving through the fourth spatial dimension. So when we are teleporting our object, we're literally moving through a fourth spatial dimension that we don't perceive. That we only perceive the three spatial dimensions, right? Up and down, left and right, forward and back. Those are our three spatial dimensions that we can move through. But if there's a fourth one that we're moving through, this is how you're just moving through solid matter as well. And then you can get stuck in it, in theory. During teleportation, the radio signals emitted by the microtransmitter became weak and non-existent and fluctuated because they were spreading out into the fourth dimension and became undetectable in our three-dimensional space. The weak signals that were barely detected represent the leakage of a portion of the radio signal back into our three-dimensional space from the fourth dimensional space during teleportation. Now, what does this part remind you of? Why is there a leakage? So let's say you teleport somebody away, or you teleport a radio signal away somewhere else. It gets dissipated throughout the ether, but there's still a little bit that's detectable. The leakage signal is being detected. Why? Remember when we have our wave, and then we have our reflected wave, and we can manipulate how much wave is reflected back through the impedance, changing the impedance. Well, what if we have a little bit of wave being reflected back? We have our wave coming here, and then boom, a little bit gets reflected back. That could theoretically be the leakage. So we have this leakage that's happening. And then the observed blending of other specimens with the walls of their containers is how the movement and rotation of specimens through the fourth dimension was visually interpreted by the mind. So pretty weird. Because some of this says now that like maybe there's more than one type of teleportation that we can manipulate. Now let's go back. Oh, I didn't want to. Oh, I should have slowed this up. Okay, quick martini break. Any questions while I eat this martini? It's Olive here. So the next thing we're going to look at is our concepts for extracting energy from the quantum vacuum. Because the quantum vacuum must have unlimited negative energy for us to tap into. It must be the reverse side of the coin of everything that we see, right? So the question then, and negative energy is just a plus or a minus sign. So either way, it's still energy. But in this situation, we want to extract that energy and use it to offset the energy that we have here. Sorry, there was a concert going on. It looks like it's over, though. Sad. Okay. So concepts for extracting energy from the quantum vacuum. So let's take a look through the contents here. So it talks about quantum electrodynamic theory. I forget what SED is. Let me take a look. I just got to remind myself what SED is. Page 6. Oh, stochastic electrodynamics. Interesting. I think they're both the basic same idea of just the energy all around us. So historical concepts for extracting energy and thermodynamic considerations. The Casimir force is associated with the electromagnetic quantum vacuum. This force is an attraction between parallel uncharged metallic plates that have now been well measured and can be attributed to a minute imbalance in the 0 point energy field. So we have this field, and even with a tiny amount of imbalance between the plates and the area around it, we still get an attractive force. So now we know the secret. Now all we have to do is change the imbalance. If we can manipulate the imbalance over here, or wherever we want, Now we're manipulating gravity. So it is the Casimir effect that we have to manipulate, but we have to do it on a different scale. I also believe this is where Thomas Townsend Brown's the T.T. Brown effect, that's where I think this comes from as well. It's all the same stuff. It's always manipulating the energy densities within a certain region to create a cavity. The primary requirement for space travel is energy. It is sometimes assumed that attempting to extract energy from the quantum vacuum, 0-point energy field, would somehow violate the laws of thermodynamics. Fortunately, it turns out this is not the case. A thought experiment published by Forward demonstrated how the Casimir force could in principle be used to extract energy from the vacuum 0-point energy field. Forward showed that any pair of conducting plates at a close distance experiences an attractive Casimir force that is due to the electromagnetic ZPF of the vacuum. A vacuum fluctuation battery can be constructed by using the Casimir force to do work on a stack of charged conducting plates, as shown in Feature 2. By applying a charge of the same polarity to each conducting plate, a repulsive electrostatic force would be produced that opposes the Casimir force. If the applied electrostatic force is adjusted to always be slightly less than the Casimir force, the plates will move towards each other, and the Casimir force will add energy to the electric field between the plates. The battery can be recharged by making the electrical force slightly stronger than the Casimir force to re-expand the conductor. So basically what this says, you make a spring, and now you're going to manipulate the Casimir force in your spring because the spring is just a bunch of stacked plates. And then if you manipulate the charge, then you can allow it to expand and contract and basically give you free energy. You rotate the charge, you flip it back. If you want it to expand, if you want it to contract, you have the charge go one direction. If you want it to expand, you flip the charge over. So you alternate the charges back and forth. And what are you going to get? You're going to get your spring, right? So that's one way where you could extract the energy and you can turn it into usable kinetic energy. So this is the one that's always interested in me. I think this is basically the one with no moving parts. Technically, I don't think they count the spring moving as moving parts. One sec. So Puthoff was one of the people that verified that generic energy extraction schemes are not contradictory to the laws of thermodynamics. For thermodynamically reversible processes, no heat flow at temperature T equals 0. However, for thermodynamically irreversible processes, heat can be produced and made into flow either at time equals 0 or at any other time greater than 0 situation, or sorry, temperature. That's temperature. That's absolute temperature equals 0. Or at any other temperature greater than 0 situation, such as by taking a system out of mechanical equilibrium. So this is where Thomas Bearden mentioned the idea of non-equilibrium systems. So an equilibrium system would say, okay, I'm going to put this amount of energy in. Maybe it's sunlight energy. I'm going to turn that into usable energy. And then I'm going to take that energy out. So you have your closed system. And this system now is not interacting with ether, and it's losing some energy to entropy as heat. Now, solar panels are actually only about 20% efficient. So only about 20% of the energy they're getting in is coming out as usable energy. And they could probably be a lot more efficient, but they've basically been banned from being more efficient. And with a non-equilibrium system, now instead of having just your energy in and your energy out, you've got another source of energy coming in your non-equilibrium system, a negative energy situation. Negative entropy, sorry. I mean, negative entropy situation. So instead of losing energy to heat, you're actually gaining energy, which is cooling down the environment. Okay. Moreover, work can be done by or done on physical systems, either at temperature equals 0 or temperature greater than 0, whether for a reversible or irreversible process. However, one is considering a net cyclical process on the basis of, say, the Casimir effect, then energy would not be able to be continually extracted without a violation of the second law of thermodynamics. Thus, Forward's process cannot be cycled to yield a continuous extraction of energy. Here, the recharging of the battery would, owing to frictional and other losses, require more energy than is gained from 0-point fluctuations. There is no useful energy cycle in this process. Nonetheless, the plate contraction phase of the cycle does demonstrate the ability to cause extraction of the energy of 0-point fluctuations. It does reflect work done by 0-point fluctuations on the matter. So basically what they're saying here is that conventional physics would say, even if you are extracting that energy, to move it back to its original state would cost more energy than it did to that you got out of it. And this is where, I don't know, maybe Eric Davis is being a little bit coy. Maybe he's just spreading disinformation, but it doesn't mean that it's not possible. It just means that that one mechanism is not doing it. Now, in addition to this, this part is really important. It still does reflect that you are actually able to get work done and extract energy from 0-point fluctuations. So this is the biggest debunk of the debunk or rebunk. So even when people come back, because this science is sound, it's irrefutable. So what people will come back and say is they'll say, yes, you extracted free energy from the Casimir effect, but they'll say because you have to pay a price to move the plates back apart, that it's not technically free energy. But it still does represent that we can extract energy from the vacuum. And then we're converting that energy into kinetic energy, or we're converting it into actual usable electrical energy through kinetic force. Let's see. So here's just another option as well in terms of doing it, which is probably going to be, I think, a little bit too over the top of my head. But basically, it manipulates radiation, and then you can use that radiation to turn it into usable energy. Now, let's go back to some of this other part here. The part that I wanted to look at here. So a tunable Casimir effect. Ground state energy reduction. EV phenomenon. Okay, quantum electrodynamics as a mathematical placeholder. No. Casimir effect revisited. Notice the Casimir effect is mentioned like all the time through this. Oh, here we go. Down here. Alternatives to the quantum electrodynamics, degradability of the vacuum. That one's kind of interesting. We might have to look at degradability of the vacuum real quick. But the ones that I really want to say, examples of the degradable of the decaying vacuum. So this is changing the energy states of the vacuum. That's what decaying is, right? So gravitational squeezing of the vacuum. We're going to look at that. Redshifting of the vacuum. Vacuum field stress, negative vacuum energy from the Casimir effect. Squeezed quantum vacuum. Dirac vacuum decay. So Dirac equations would talk about the latent energy of the vacuum. And that's about it. So we're going to look at some of these pages from 30 to 37, but let's go to 25 real quick first. Page 25. Okay, the possibility of continuous conversion of vacuum 0-point energy to other forms requires that, in principle, vacuum energy must be degradable. That is, constantly consumable. Not just that there must be a surfeit of energy in place to harvest. So it can't just be that there is a well of energy. It's got to be constantly consumable, basically unlimited. This perspective leads to a remarkable question for deeper explorations of quantum electrodynamics. It turns out that the mathematical structure of QED is based on the formalization in which the vacuum mode structure and the vacuum fluctuation energy per mode are quantized in what could be called hardwired fashion. That is, they possess fixed immutable values. Therefore, at the end of a cycle hypothetical type 2 machine, so he's talking about what would a free energy machine look like for a type 2 machine, in which matter, bolt, and vacuum mode structure have been returned to their original states. The vacuum modes must of necessity contain at a minimum the same hardwired energetic content as before the cycle. Therefore, assuming a local detailed balance in energy conservation, continuous conversion of vacuum ZPE to other forms via type 2 machine is, from the QED viewpoint, forbidden in principle, since the vacuum, as described by that QED formulation, is non-degradable. Okay, that part wasn't as interesting as I thought. Okay. So even though he says that the 0 point fluctuations seem hardwired, that the vacuum is still degradable. So how do we degrade it? Gravitational squeezing of the vacuum. In their study of traversable wormholes, Hochberg and Keffart discovered that the gravitational field of any astronomical body produces a zone of negative energy around it by dragging some of the virtual quantum. So here's your answer right here, guys. It's a matter of how we perceive negative energy. So a gravitational field of any astronomical body produces a zone of negative energy around it. This may be the lens stirring effect, I'm not sure, or the frame dragging effect. Some of the virtual quantum, aka quantum ZPF, downward. Now, this is interesting. Why is this pulling of it downward interesting? Because this is what we saw from the what was his name? The Michelson-Morley version that we looked at. Here it is. Martin Grosnick. Oh, sorry, I didn't wasn't sharing the right thing.
Horizontal rotation.
So again, when we spin our interferometer this way, we get nothing, but we flip it over and we spin it this way, then we see our interference pattern move. So that interference pattern was a movement. You flip it over like this, and what happens?
On the screen.
Now it starts moving. Why is it moving? Because of the 0 point energy is pulling things downward. That's the reason why you see it shift. Is you have this downward ether of 0 point energy. That's what the ether is the 0 point energy.
You are now able to clearly see a movement of the interference fringe pattern.
So we can see that movement of the interference pattern. And then if we show it right here,
the interferometer,
you can see that this is because it's hitting the area where it's exactly parallel to the Earth. So where it's exactly parallel, that's where you see the end point. And then depending on which way you go from there, you're going to see the shift because it's perfectly based on a downward pulling effect, which is, you would argue, gravity. Well, that's because that's what the 0 point energy is. The 0 point energy of the vacuum state is what we perceive as gravity. They applied their discovery to the problem of creating and stabilizing traversable wormholes. Their quantum optics analysis showed that there's a distortion of the vacuum electrodynamic ZPF due to the interaction with a prescribed gravitational background, which results in squeezed vacuum states that possess a negative energy density. So again, this is like taking your turkey baster, squeeze your turkey baster, and then you're going to see what was in the turkey baster get shot out through the front of it. Water, air, whatever it is. Squeezing of the vacuum is a quantum process that is roughly analogous to the compression of an ordinary fluid. So you take your fluid, squeeze it, the compression of the fluid, shoot it out. This means that as the vacuum field is continuously being squeezed by the gravitational field of the body, its energy is constantly being degraded with respect to the undisturbed remote vacuum field. Well, that's interesting. So that means your mass, the real mass, adding mass, as His Highness said, is basically pulling the 0 point energy down towards it. Why is that important? Because think of the sun. The sun is massive, so it's pulling the 0 point energy towards it. And then what's happening? Fusion is happening. Gravity. That's what gravity is, right? Think of gravity as it's not really doing the pulling, but what's happening is it's bending the geometry of space-time to such a degree where the 0 point energy is basically following gravity downward. into a single point, compressing it. Squeezing of the vacuum is a quantum process. I already said that. The magnitude of the gravitational squeezing of the vacuum can be estimated from the quantum optics squeezing condition for the given traverse momentum and equivalent energy eigenvalues of two electromagnetic ZPF field modes, subject to the squeezing condition. Blah blah blah. Okay. Schwarzschild radius. This condition simply states that a substantial gravitational squeezing of the vacuum occurs for ZPF modes where the wavelength is greater than 8 pi rs. Okay. It's not clear whether this mechanism can be exploited to extract energy from the vacuum. Conservation of energy suggests that one of two possible outcomes: the loss of energy is injected into the gravitational energy of the body, or the lost energy reappears as accumulation of positive energy density elsewhere in the universe. So, I mean, to me, that's the answer. So, if you are extracting energy from the environment, where's the energy going? Well, it's being radiated outwards. It's being radiated outwards, right? Like that's what the sun is doing. That's what cold fusion is. So, cold fusion, your energy density is getting so strong that fusion begins, and it's pulling that energy from the environment around it, and then it's shooting it back outwards. I mean, that's, to me, explains how the sun works. And then the question is, how do you achieve your energy densities that are high enough to ignite that cold fusion? I mean, that's the main idea of cold fusion. It's not necessarily that easy to invent. The science here is only, like, even this paper is from early 2000s. You have to realize it takes not just the willpower, but you have to have the right tool, the right materials to be able to pull this off. I think that if you think about, okay, what does it take to pull this off, right? To even test this requires high powered lasers that can do extremely high frequencies that are probably millions of dollars worth of equipment. And now you're only getting even small outputs. So how do you improve your output? How do you make this better? Any of these concepts, teleportation, etc. You turn it into microchips. You miniaturize it. What's a miniaturized version of these experiments? Microchip. Maybe a microchip is the size of my nail here. Maybe even smaller than that. Right? You make little tiny microchips that have the exact engineering requirements that you want to produce an effect. And then you just scale it up. That's the answer. You do it in a scalable way. And so then the smaller you can make it, the better it works. This is why a lot of these people that are analyzing these specimens they say come from UFOs, they're talking about like the best possible things that you're putting it together at the atomic level. Like one atom of this, one atom of that, you're making a metamaterial. So this is where this idea gets connected to metamaterials. So, okay, so we can extract the energy, but we need this right exact configuration of properties of these elements. Okay, well, the best possible thing we can do is we can put it together at the atomic scale, the smallest possible, nanoscales if we can, right? Like a little bit of this element, a little bit of that element side by side. It's going to produce some type of electromagnetic effect, and then we're going to scale that up. To me, this is why the next frontier has always been like semiconductors, microchips, because the smaller you can make it, the better. This kind of goes back to the glitter conspiracy as well. Like, why is glitter so important? It's probably not the glitter. It's probably the production mechanism that allows for very small cutting of materials, right? And this is also why, like, you're seeing AI get so powerful, is that our microchips have gotten super powerful. You know, so we're able to create like very, very powerful effects using very small microchips. And superconductivity to me is another key element to this. Like, superconductivity is like taking your semiconductor and cranking it up and breaking it so that it starts to have quantum type effects. There's got to be a connection there, in my opinion. I don't think it's a coincidence that like Ning Li and Potklanov, like even A.V. Eskridge, all these people just like start disappearing. Like everybody who seems to look into semiconductors and superconductors related to this, like they seem like they're onto something. T Walker, I don't want to be offensive to you, but this is real science that you're looking at here. This isn't Harry Potter. So if this is like too complicated for you, I suggest you go back to video games, because what you're looking at here isn't make believe. Like, this is the actual hard physics math that you're staring at right here. None of this has been debunked. None of this is fake. This is all 100% real. Like, this is the problem with like normie people, like people that are like CNN and Reddit brains. This is the problem with society today, is that people don't realize what real science looks like anymore. They see this science here and they go, oh, well, this just must be make-believe, well, even though they don't understand a single word of it. The scientists that he's referencing here are the people that came up with physics, all modern physics that we know today. Schwinger and DeWitt. Like, why do you think that there's like a DeWitt particle? The what is it? The DeWitt effect. I'm forgetting the full name of it. Schwinger limit. Why do you think there's something called the Schwinger limit? Because these guys are like the scientists that like came up with all of this. My followers are smart, dude. I don't know why you're being like a kind of a dick in general. My guess is you don't understand any of this, though, based on your reactions and your hostile reactions to my followers. So if I were you, I would do less reading and then much less judging of what people believe, because all of this is proven science. The question really is, can it be engineered? So as we saw from this other video that I played, I'm only going to play the first few seconds of it here for you guys. It's not a physics problem. It's an engineering problem. I pulled it from his other page, so I have to show it on my Twitter channel, unfortunately, because I didn't download it. But yeah, sometimes it's okay to chat with people, but it's a matter of engineering it. It's like, we know what the math says. Math says it's possible. The issue is, how do we engineer it to get it to work? And that's where it becomes easy to suppress it. Like, this is out there. Anybody can read this. If you you take this to Neil deGrasse Tyson, and Neil deGrasse Tyson is going to say, sure, all the math works, all the theory works, but how do you make it actually work? Show me an experiment with it working. That's what Neil deGrasse Tyson will say. You know why he's going to say that? He's going to say that because he can't debunk any of this. He's going to say, yes, it all works out theoretically, but it hasn't been proven through academic sources publicly. And that just means that, yes, it works, but the answer is, okay, it works, but you have to like actually prove it for me. I want to see it with my own eyes. Well, okay, no, right? That's what the government says. Government says, if you're going to show me mass reduction, which is what we talked about at the beginning of this stream, that's going to be classified. If you make anything related to it, any patent related to it, we can just classify it. And then that's it. You either get pulled in and you're selling it to us now, or, you just disappear, or it disappears. Okay, let's go. This is more about the Casimir effect and how you can manipulate it. The part that I wanted to go to is squeezed quantum vacuum here. Yeah. Yeah, part of it too is pretty funny. Like, I hate, you guys hear me rip on a lot of the UFO community. Now, not you guys, which I know some of you guys are the UFO community, but a lot of the other people out there. And the reason why a lot of the other people that I have issue with their view is that they think that the government's hiding aliens from the world in some massive conspiracy, but they also think the government will just tell them. They also just believe the government at face value about everything they say otherwise. So they're like, yes, I believe simultaneously the government has this major conspiracy and they can cover up physics and all this stuff. But at the same time, I trust the government to tell me what to do. And it's like, you can't hold both of these ideas in your head. And the truth is, it's not that simple either. The government isn't some monolithic being. The government's made up of individuals that all have their own agendas and plans. And when those mix together, that's where you get, sometimes bad stuff happen, right? But in general, the UFO community just like doesn't really seem to understand that the government is not going to tell them about this technology. not willingly. No chance. Too dangerous. Too dangerous, guys. Okay. This has got to be the most naive statement I've ever seen. The government works for the people. The people have the power to expose them. Yeah, like what I've been doing for like the last 9 months, 12 months, exposing their secrets, exposing the science that they've kept hidden. It's not as easy as it sounds. You can do a FOIA request. Now, this is the most naive there is. So, see, this is the problem. Like, people like T. Walker here think that we know everything the government knows. Yes, the government has this major conspiracy going on and they lie about stuff, but they're not lying about this. They're not lying about this. We could do this. Excuse me. I tell you what, you do the FOIA requests. How do you FOIA request Lockheed Martin? So the government has these papers. These actually papers did come from FOIA requests. You're actually looking, by the way, you're looking at these papers because of FOIA requests. So you see at the top of every page, it says unclassified for official use only. That's because in 2018, these papers were found via FOIA request. That's the only reason why we have these papers here. Oh, I wasn't showing you. See how it says unclassified here? This is exactly the thing you're talking about. This is literally a paper that they classified, they kept hidden from people. This is where people don't seem to realize this. Like, we're looking at the information that was classified. So the very thing that you said that we could do, we did that. And this is the science that we found. They were hiding this from us. Are you caught up yet, T. Walker? They generally don't work because the answer is, if you're trying to find, one question is, do you want the science behind how it could theoretically work? Yes, there it is. Because they need to have that out there. Now, do you want to see an orb flying around and teleporting? Well, that's held in the Lockheed Martin stuff. They don't have that. Lockheed Martin's the one that builds that, or what have you, right? That's where you're not going to see it. So the idea that if you just do a FOIA request, you're going to get all the information there is absurd. This is the problem with people that don't seem to understand that things aren't as black and white as trust what the government says. They've got built-in processes to make that happen. We trust them. No, they built the processes so that you can never get the truth. You can get pieces of it because it's right here. But most people will say, like I just said, Neil deGrasse Tyson will say, well, prove it to me. Well, the problem is, you're going to who? You're going to FOIA the people. Who are the people that can prove it to you? The Lockheed Martin, Northrop Grummans. Those are the people that have the technology. These are the people that are just writing the scientific papers. The government isn't out there producing it. They are buying it from third-party defense contractors. This is what people don't understand. Like, show me the government research facility, right? There's certainly ones that are help funded by it, but show me the one that's actually producing the stuff and putting it together that the government owns 100%, right? It's defense contractors. That's how the military works. This is why we set the system up this way. Okay, next thing. So let's read this part, and then how deep are we into this? Okay, yeah, we're probably going to stop pretty soon. Gravitational squeezing. In their study of traversable... Oh, wait, we already read this one. Where's the thing? Down here. Wait, did we read that one? Yeah, we read that. Okay. Negative vacuum from the Casimir effect. Oh, here it is. Squeeze quantum vacuum. It was discovered in 1965. So now, again, we've got dates here, right? So 1965 tells us pretty accurately like how far advanced we had already gotten. We had gotten quantum field theory pretty advanced in 1965. That was 60 years ago. Were you considered a normie before you came across MH370 videos? I was pretty much a normie, guys. Pretty much a normie. People actually get upset with me that I don't buy into more conspiracies, actually, which goes to show that I'm not really a conspiracy guy in general. Like, I don't think there was a second shooter in the assassination attempt. I knew for sure that woman in the crowd that people were talking about today was not really the FBI lady. This is what I've been talking about, guys, for the last few days. Like, a lot of people in the conspiracy world, like, everything is a conspiracy. Like, every single thing is a conspiracy. And that's where they get you, man. You're hitting on 19. You know, you had an assassination attempt. The person was definitely not a Trump supporter. That they came after him, and instead of just taking the win, we had to claim there's a second shooter. We have to claim that like the guy's somebody did the shooter is somebody else, which finally that's mostly gone. But there's still people out there going, that wasn't even the right shooter. They're hiding the real shooter somewhere else, which I don't even understand why we have to do that. And then now the new theory of this FBI woman's in the crowd. This is all planned operation by the deep state. Like we're working with very little evidence and facts, and we're just drawing like conclusions based on it. And this is the problem. So this is why I avoid a lot of conspiracy stuff in general. Now, that doesn't mean that this is not a conspiracy. Obviously, hiding the science is probably the biggest conspiracy ever, frankly. But it means we have to follow the evidence where it leads, not just come up with stories that don't make any sense, right? Because we want there to be some grander explanation to everything. And I guess we're interacting with T. Walker. Just because something's classified doesn't mean it's automatically free energy. That logic doesn't really follow, right? It's not that because stuff is classified, it has to be free energy. It's that the stuff that is classified is literally called concepts for extracting energy from the space-time vacuum, right? That's literally the definition of this paper that we're reading right now. This paper is literally about extracting free energy. That's what it's about. This other one I was showing before is literally teleportation physics study. So, I mean, read whichever one you want. I guarantee you've never read these papers. You probably should. And these papers are not written in a way where like you have to be a PhD to understand them. Like you can understand the basic concepts just by like being a normal person. That's what I like about these papers in general. Yeah, and now we're getting into the part where it's like you're arguing both sides, right? At first you said if it existed, we'd be able to FOIA request it. And we did, and it did exist, and we FOIA requested it. And now you're saying, well, why would they declassify it, right? Well, maybe some of the people wanted the information out there. Maybe they decided they couldn't hide it. I mean, you tell me, do FOIA requests work or not, right? It's declassified because, like you said, when you FOIA request something, they have to give it to you. Unless they use one of the Obama era exemptions, like they've done with the MH370 videos every time I've tried to get anything. The NSA comes back and says Obama era exemption to be kept secret in the interest of national defense or foreign policy. Now, in this case, these are just scientific papers that don't tell you exactly how to engineer it. They tell you the science and concepts about how it works, but they don't say take a 4x4, circular plate of, aluminum or whatever the materials are, right? Like it doesn't tell you exactly how to do it, right? So that's the difference. But these are important questions to ask because a lot of normie brained people don't realize like what does logic and reason look like when you are trying to determine if something's real or something's fake and what the significance of something is. And the bigger questions of like how and why do they suppress it? And we can't know all the motivations. I think that some people want the information out and some people don't. My guess is when the time came to declassify this, there was a meeting that happened or a discussion where they determined if it was appropriate to release to the public or not. And they decided that it was appropriate, right? So that's the thing. Well, this is going to I'm not going to keep interacting with you, but I just want to let you know here. It's like, why would the government give you anything to work with? Well, you're the one who just told me they have to, and that's the point of FOIA requests, right? So you tell me, can we get the information from them or not? The answer is they're not giving us anything that's going to let the common man build a doomsday weapon. This isn't enough to be able to build a free energy device. This is not a manual on how to build a free energy device. This is a manual on how to understand the physics and geometry of the physics so that you could understand the concepts of how it could be possible. That's the difference. So one, it's fine if theoretically they explain it to you, but if it's actually on how to build it, you're not going to find any of that, right? You are not going to find any of the things about this is how you build it. This is how you can make a free energy device. You can see the patents because the patents are in some cases openly available, but not if the government uses their Secrecy Act and then they classify the patent. Then you're not going to see that either. So that's the answer. Okay, let's move on. It was discovered in 1965. Quantum field theory has the remarkable property of allowing states of matter contained in local regions of negative vacuum state energy density or negative fluxes. In general, the local vacuum energy density in a quantum field theory can be negative due to the quantum coherence effects. A primary byproduct of this discovery is that the squeezed quantum vacuum, which later gave rise to a new phenomenon such as the gravitationally squeezed vacuum discussed previously. So we talked about gravitationally squeezed vacuum. Substantial theoretical and experimental work has shown that in many quantum systems, the limits to measurement precision imposed by the quantum vacuum zero-point fluctuations can be breached by decreasing the noise in the observable or measurable quantity at the expense of increasing the noise in the conjugate observable. So what they're saying there is you can take energy from one location as long as you move that energy to a new location. Hey, Jake, have a good night, brother. We're taking off in about 5 or 10 minutes here as well once we finish this part. Thank you for being here. Appreciate you, man. So to me, that's the way this reads, is that you can actually move energy from one location as long as that energy rematerializes in the conjugate, which is the other location. Where was that? And reducing the noise. What does reducing the noise sound like? Reducing the noise is like basically getting rid of all the electromagnetic waves that are happening here. So moving them all away, which would be a negative energy zone, right? Like what we see with the plane video. They're decreasing the noise. They're moving that energy from one location to the other. Ashton, a scalar mass reduction technology capable of neutering incoming ICBMs and therefore explain why we are escalating with Russia without seemingly any fear of consequence. Long and short, thank you for the donation. First of all, is yes. This is exactly what I think we're doing. I think that we know that ICBMs are basically no threat to us whatsoever. We are not afraid of escalating the conflict with Russia at all. In fact, Russia is the one that keeps talking about their hypersonic weapons, blah, blah, blah. Like they're just a dog that's barking. You know, they're a dog just barking. And we're going, sure, yeah, your hypersonic weapons, that's cute. Go outside and play in Ukraine, right? Because if they were to shoot anything at us, A, we can teleport it back onto them, and B, we can just annihilate it instantly. We might be able to shoot it out of the sky with directed energy weapons too. So we have a lot of options. I don't think that we're very afraid at all. In fact, the fact that we have not invested heavily in anti-ballistic technology tells me that we're not afraid of it. This is also part of the reason why we have not been attacked. I mean, UK has not been attacked. America has not been attacked. I would even question the why Israel is being attacked this much and why we're defending Israel. We've had very strong ties with them. I think all the countries that we defend are probably the countries that know about this technology in general. And we don't want to deploy it because we don't want the world to know how advanced we've gotten it. Same reason why we don't deploy nuclear weapons, right? Once we start deploying these weapons too, now it's going to start getting wild for everybody, right? Really, really dangerous. Yeah, and plausible deniability is another great reason why they show this information. So part of the reason why they release information like this is because then when it comes out, they don't have to say that they lied. They can say, we didn't lie. We told you how the science works. That's why we declassified these papers. And then people will go, well, why didn't you tell us about the patents? And they'll say, because those patents were secret, because those patents can create weapons that are of mass destruction. So we had to classify them. That's what they'll say. But then they'll come back and say, we didn't lie. We showed you all these papers that we commissioned. We declassified them all so you could figure it out. We just didn't show you how to build it exactly. That's plausible deniability. Therefore, and if you think about how this plays out, even if today they come out and they say, oh, yes, we have 0-point energy, people will be mad, but here's your answer. They're just going to point to these scientific papers and say, we always showed you that we knew about 0-point energy. You just weren't listening because you thought for some reason these papers by Eric Davis were fake. Even though Eric Davis is like a super prominent physicist that's been working in the government area for decades. And normally people will just go, oh, yeah, well, okay, sure. Because they don't even know anything about the situation. Now, that is, by the way, the definition of plausible deniability. Okay. Where is it? Okay, this next sentence, is this one really this long? Substantial theoretical and experimental work has shown that in many quantum systems, the limits to measurement precision imposed by the quantum ZPF breached by the decreasing noise on one observable and increasing the expense of the noise in the conjugate observable. At the same time, the variations in the first observable, say energy, are reduced below the 0-point energy fluctuations such that the energy becomes negative. So you're reducing the energy to a point where it becomes negative, below the equilibrium state. So your equilibrium state's here. Everything above this is positive. Everything below this is negative. So if you move it below the negative energy state, you squeeze your turkey baster, then you're going to have a resulting counterforce that's going to happen that we're going to see. Now, what do I think we're talking about here when we're talking about reducing the energy to negative energy? We're talking about what we see in the MH370 video. Specifically, we're talking about this thing right here. Oops. So if you want to know what reducing the energy state in the polarized, in the vacuum, it looks like, this is what you're looking at. This is it. These orbs are reducing the energy state in the sphere of influence around them. And they're basically just breaching through to the negative energy state behind that, or producing a negative energy state, producing a squeezing effect right here. That's why they're colliding right here. And that's why right there with that negative energy, that cold zap, we're seeing this negative energy event occur. Negative energy event must be counteracting the mass of the plane. This also explains why in the final frame here, we see a blur. They're basically already starting to create a field that's almost powerful enough here. The moment it goes dark in this next frame, that has to be when the Casimir effect is breached, or not the Casimir effect, the Schwinger limit is breached. The Schwinger limit. Space is becoming nonlinear. You're seeing this non-uniformal, like endothermic reaction here. And like within the blink of an eye, it's self-correcting as well. So it only lasts for a fraction of a second. And then basically, I guess most people think of it like water rushing back in, but it's not quite that simple. Because the tank is so massive, the effect of it rushing back in is like minimal, let's say, to our reality. That's the part I struggle with the most in general, but the way that's been explained to me and that I've thought about it is that like it's just the plane that's moving, not all the area around it, not the other medium. And then maybe there was some kind of small ripple effect. I don't know. It's interesting. Okay, let's go back to this other part. Where were we reading that? Squeezing is thus the control of quantum fluctuations and the corresponding uncertainties whereby one can squeeze or reduce the variance of one physical observable quantity provided the variance in the conjugate variable is stressed and increased. So again, what he's saying here is you squeeze this side and this side's growing. Whatever you do to this side, you're going to have a corresponding increase elsewhere, which is what we would expect from physics. The squeezed quantity possesses an unusually low variance, meaning less variance than would be expected on the basis of the equipartition theorem. I'm not sure about that. Equipartition theorem. One can, in principle, exploit quantum squeezing to extract energy from one place in the ordinary vacuum at the expense of accumulating excess energy elsewhere. There it is right there, guys. So if that does not convince you, then let me see if I have Thomas Bearden. Oh boy, I have so many. I'm just going to go to one randomly here. I don't know which one's the best one. Let's do this one. Oh, wait, what? Can't play the video? Weird. Let me try this. Oh, weird. Well, let me share those videos, guys. I apologize. So basically, Thomas Bearden talked about cold explosion. What's a cold explosion? Endothermic event. So basically the exact same thing that Eric Davis is talking about right here in this paper. He's saying that you can extract your energy from one location, you can move it to another. That's the idea behind scalar phase conjugation and scalar physics in general, is that we can manipulate the gravity, we can manipulate the 0-point fluctuations of the space-time all around us. But if you move it from one location, it's got to go somewhere else. So if you extract energy over here, energy's got to show up over here, or the mass. The squeeze state of the electromagnetic field is a primary example of the quantum field that has negative energy density and negative energy flux. Such a state became a physical reality in the laboratory as a result of the nonlinear optics techniques of squeezing, that is, of moving some of the quantum fluctuations of laser light out of the cosine part of the beam and into the sine part. The observable that gets squeezed will have its fluctuations reduced below the vacuum 0-point fluctuations. So when you squeeze this area, the vacuum 0-point fluctuations are going to become negative. You're going to have this negative energy. The act of squeezing transforms the phase space circular noise profile characteristic of the vacuum into an ellipse whose semi-major and semi-minor axes are given by the unequal quadrature uncertainties. This applies to coherent states in general, and the usual vacuum is also a coherent state with eigenvalue 0. So what he's saying here is there's a natural equilibrium coherent state in our vacuum all the time, and we can manipulate that down or up. So they're saying here's your baseline. You got your baseline energy that's all around us. You can reduce the local energy in that area and you can get to a negative energy, or if you increase it, you get to a positive energy. So instead of looking at negative energy as this magical purple energy, it's the same energy. It's just a matter of your energy state being below the natural energy state or higher than the natural energy state. That's what I think is interesting about it, because of that, that means that the negative energy is just energy. So if we can extract that energy, we're creating a negative pressure zone in the area where we are extracting it from. And if that's the case, then looking at the problem of teleportation now becomes a matter of geometry and squeezing the vacuum and manipulating the 0-point fluctuations of any particular space, the area around the plane or the area where the plane is going to show up. So that explains why we're seeing in those videos, we're seeing this squeezing effect happen here. So I think that what the planes are doing, the orbs are doing, they're squeezing that area and they're basically pushing that plane out of that local area into a new location. And this goes to show you that space-time is a medium that we can manipulate, but not just a medium, but a medium filled with energy. That's what we're seeing happen right here. This is why they're squeezing together. There's no way that somebody's going to make this up. It's too complicated. It's all consistent with these classified papers that weren't even publicly available when this video was theoretically made in 2014. All these papers were declassified recently. And sure, there's other public stuff, but not stuff that's specific enough like this. So you're basically seeing these orbs. And when we talk about creating gravity, we're just talking about manipulating energy densities. So manipulating the energy density of the region of space around the plane. This is causing the plane itself to maybe undergo a phase conjugation event. That's the part where I can't say 100% I fully understand. If like the plane's actually, like what's really happening here? Like is the plane going through another dimension? Is it just reverting to energy and then back to matter again? Or is it just, popping up somewhere else instantly? Is there a difference between any of these things? Or are all these things the same thing? And it's just how we observe it that matters? Like, I don't know. End of the day, it's some form of teleportation that's occurring there. So the part that I wanted to talk about real quick related to these videos. Actually, let me see if there's anything else I want to talk about on this. Okay, we talked about that. Okay, I think that's good enough. So now I wanted to briefly talk about this related to the videos. So first of all, you can imagine just extracting energy from the environment would be, free energy. That's the definition of free energy. Free energy is not about your energy being free, although it does have that side effect. Free energy is about the idea that you can extract energy from your environment. Therefore, we don't need like sun energy or any other energy out there. Like it's the cheapest form of green energy. Now, when we're watching these videos, what this means is that these orbs have multiple purposes. Okay. It's actually just if you want to catch up, Walker, there's like at least 3 scientific papers just between 2020 and 2024. If you do a quick Google search on traversable wormholes, that argue that wormholes are traversable. That's why they call them traversable wormholes. And the difference between a wormhole and a black hole is that a black hole has an event horizon, where if you go past the event horizon, there's no escape. You're going to get ripped to shreds. In a wormhole, it has potentially the traversable effects, but there's no event horizon, which means the G forces you feel in your wormhole are not going to rip you to shreds and you can escape it. This is the major difference. Otherwise, a black hole and a wormhole are analogous to one another. This cold, black, dark event that we see. And that's important because these orbs have three purposes, in my opinion, which goes to show the technological achievement of these orbs we're about to see is incredible. So right away, we see the orb come flying in at thousands of miles per hour. So we see that this orb itself is displaying what we would call gravity manipulation technology. From the other video, we can tell that it's a plasma sphere. We can tell there's a plasma field around this orb, which shows us that it's potentially cold fusion. It's a miniature star. It's extracting energy from the vacuum all around it while it's traversing. That's its energy source. So it's self-sustaining, which means that this thing doesn't have propulsion that's coming out of the back of it. So it's actually a field of plasma, maybe with something inside of it, but not probably a person, some kind of mechanical device. And it's self-sustaining. It can move for at least a while, potentially longer than a while. Now, it's also targeting and homing in on the plane. So I showed a patent about using plasma, laser-induced plasma, to be a decoy for homing missiles. This tells me that this might be exactly what we're looking at right there. It's some kind of homing mechanism. Now, why is it mapping the plane right here? Right? This was always a big question. Why is this mapping the plane? It's spinning around the plane every direction. Well, the answer is not because it necessarily wants to get the size of the plane, the height and the length. It wants to know the mass of the plane. Why does it want to know the mass of the plane, guys? Well, we just showed it earlier today. It wants to know what the mass of the plane is because it needs to figure out how much negative energy is required to make poof, that happen. How much negative energy is required, guys? We learned it earlier today. How much negative energy is required to make this plane go poof like that? The answer is exactly the same amount as positive energy as the plane has. So when we saw our elastic collisions, we want to get the infinity collision. The infinity collision happens when the negative mass equals the positive mass. When they equal one another, the denominator on the mass, acceleration, equals force divided by mass. When mass is zero, acceleration is infinite. We want infinite acceleration. So they're actually checking here to figure out what the mass of the airplane is. They figure out the mass of the airplane, and then they move into formation. And they figure out the mass of the airplane in like 15 seconds, which is really fast. And then they're moving in position to create the singularity, to break through the Schwinger limit, cut through our reality. Poof, that's a wormhole. To produce the exact right negative energy that's required, or get very, very close so that your object's able to basically move at the speed of light. Once it gets to zero mass, then the math says that we can basically have that object teleport somewhere else. Now, here's another analogy related to it. Quantum entanglement. Quantum entanglement allows for our object to be here and then teleport to over here. Why can we pull that off with the math? Because the mass is zero. They're massless particles. If it's a massless particle, like a photon, then you're going to have your situation where your mass is so infinitesimally small that your particle can be in two places at once. So if we take our large airplane or my martini glass and we shrink it down mass-wise to the same as a particle, now theoretically we can do quantum teleportation with it. So the secret is mass reduction. That's the secret to the videos. That's the secret to what the government's hiding. That's the secret to what the government won't let be made publicly available. Is that if you reduce the mass, if you create a positive and negative masses that are equivalent to one another, and you make your mass now zero, now you can teleport. Now you have quantum entanglement. Now you have ER equals EPR. A wormhole is equivalent to quantum entanglement and quantum teleportation. This is the answer to the videos, guys. And it's the same science that I've been telling you guys for months and months and months. No different. ER equals EPR, a unification of quantum, of general relativity and quantum mechanics. It's based on 0-point fluctuations all around us and being able to manipulate the 0-point fluctuations. So you imagine that we're in this space-time. I'm stuck in my fish tank right now as you guys are watching me here. And we manipulate, we pull the energy out of this side, the energy reappears over on this side. We create this negative energy pressure differential, which is the same as what mass is doing. What my body is doing to the space-time around us, what the Earth that we're on right now is doing to the space-time all around us, manipulating the 0 point fluctuations. That's why this next paper that I'm in the middle of reading, I'm going to pull it up real quick. So then the question is, why is Hal Puthoff the guy? Shit, where is it? So let me pull this up. Yeah, I like to try to visualize it for people. So why is Hal Puthoff the guy that I've been targeting so hard on this? Because the more I read about people, for the record, I want you guys to realize I didn't know who any of these people were. Like I kind of knew their names, but I didn't really know what they were known for before I started getting this investigation. I started noticing that Puthoff has tons of 0 point fluctuations, 0 point energy papers, tons. This one attracted my attention most recently. I started looking through his stuff. 1988. So remember, Thomas Bearden was talking about this stuff in the 80s. Wait, where is it? Gravity as a 0 point fluctuation force. Sorry, what? Okay, so right now I already know Eric Davis and Hal Puthoff have to know one another. So Eric Davis was writing teleportation physics study and extracting energy from the quantum vacuum. And he was talking about physics that we're seeing right there on this paper from Hal Puthoff in 1988. So he either knows him or he's reading his work, right? This are the only two options. And he obviously is very familiar with his work because you read this, and now we're talking about exactly what we mentioned. Gravity is the energy density between space-time, the differential of it. Sarkov has proposed a suggestive model in which gravity is not separately existing fundamental force, but rather an induced effect associated with the 0 point fluctuations of the vacuum. In much the same manner as the van der Waals and Casimir forces. Sorry, van der Waals is what I was thinking about before. So van der Waals force is like two charged particles that are super close together. They'll exhibit a force. The Casimir force is the macroscopic version of that, where we can take plates and put them close together, and they'll start to attract when they get really close. So basically what he's saying here is that, and this was 1988. So keep in mind, in 1988, in the early 90s, most people thought gravity was a fundamental force. Theoretically, they thought it was like the weak force, the strong force, the nuclear force, and whatever last one I'm missing. They thought gravity was a force like that. But it turns out it's not. It's a property. It's an interaction. And this is what he's saying, is that basically it's an induced effect associated with the 0 point fluctuations in much the same way as the Casimir force is. In the spirit of this proposal, we develop a point particle 0 point fluctuation interaction model that accords and fulfills with this hypothesis. In the model, gravitational mass and its associated gravitational effects are shown to derive in a fully self-consistent way from electromagnetic 0 point fluctuation induced particle motion, the Zitribuergang. Now, when I saw this, I went, whoa, Dave Rossi and Salvatore Paez were talking about the Zitribuergang. I didn't even know what it was. So what they're saying here is that when they were talking about, anybody who was talking about the Zitribuergang, what they're talking about here is that gravity is not its own force. It's an interaction of the 0 point energy around us. Because of its electromagnetic 0 point fluctuation underpinning, gravitational theory in this form constitutes an already unified theory. So what they're saying here is this is a unification theory. They're saying that once you realize that the 0 point fluctuations are what is causing gravity, it's basically the energy states of mass all around us. This is a unification theory of quantum and macro. This explains why quantum mechanics behaves the way that it does, and macroscopic general relativity behaves the way it does. Is because, yes, gravity is the side effect of bending space and time by mass. And what is space and time? The 0-point fluctuations. So they're manipulating the states of the 0-point fluctuations all around us. That's what gravity is. So when you look at it like that, then you say, okay, well, in order to create gravity manipulation, all we need to do is manipulate the 0-point fluctuations the same way that mass is doing it. Yeah, the Earth is still round, guys. Unfortunately, for any of this to be true, the Earth has to be round. So this is bad news for my flat earthers out there. There's no way that the Earth can be flat, unfortunately. None of this science works if the Earth is flat. It has to be round. So I apologize for that for those people in general. Although, hey, I'll throw you guys a bone for my flat earthers. If the world is a simulation of an extra dimensional state, then in a sense it is flat. If you're looking down on it from the fourth dimensional state, we would look flat, probably to them. Flat, quote unquote. The same way where two-dimensional space looks flat to us from the third dimension, right? So that's how I would look at that for people who want to believe in flat Earth. The part about flat Earth that I believe is the part where they say it's a simulation, right? In theory, what we're dealing with here is a simulation as well. I think that's the answer. I mean, simulation takes on a little bit different meaning in this context because it just means that, like, we live in a designed universe or designed cosmos. There's some underlying framework to it, rules to it, but we can break through those rules theoretically. Welcome to Flat World. It's flat universe time, guys. Well, kind of though, right? Because again, this basic concept, where's my paper? The basic concept is if the world is flat, right? So how do we create a wormhole? We bend it on top of itself, and then we poke a hole through it. Why do we use this as an analogy? Because if you're looking down from the fourth dimension, our three-dimensional world looks flat, like this. And if you bend it at the fourth dimension, like this, now you realize that all points in space and time are actually connected. We just don't perceive them because I'm over here and you guys are over here. So we seem like we're super far apart. But if we look at it from the fourth dimension, bring those points together, really you and I are right next to each other. Everybody who's watching this, you and I are right next to each other. We're right next to each other. I see you right there. Ooh, I see you. I see you, Brandon. I see you, James. I see you, Yogini. Right there. Anyway, just kidding, guys. Okay, guys, I think that's good enough for tonight. So this is where I wanted to start with the free Friday stream or free energy Friday stream. I want to talk about the 0-point energy fluctuations. Why is this important? Because now we are just simply trying to figure out how do we extract that energy? What are the mechanisms by which we can extract it? I've already said this multiple times as well, is that the ways that I think that we can extract it are multiple. Cold fusion, I think, is one method of extracting energy from the environment, from the 0-point fluctuations. The Casimir effect, we saw the spring effect. So once again, this is proof that we can extract energy, workable energy, from the environment, from the 0-point energy field. The issue on this side is that you have to undo the spring, you also have to work. So this is the counter argument. And then the third way is, I think, by manipulating magnetism. And that's the way that EtherTech has been doing it, which is through a magnetic motor. Manipulating magnetism to be able to convert the 0-point energy fluctuations to actual usable energy that can produce work. So there you go, guys. Okay, guys, I hope you appreciate the free Energy Friday stream. You guys have a good night, and I'll play us out with Not As a Corniest Song, guys. I appreciate you. You guys have a good weekend. I am going to post a bunch of videos this weekend of some of these concepts, including the one that we looked at earlier today. I hope you guys enjoy it. Love you, MH370X. Peace out, y'all.
Out in the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole. wormhole flow. We're talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum, squeeze so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course. Talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. Thin shell formalism, plates so fine. Spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plates, creating the throat, open the gates, from Earth to the stars in a single bound, a shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread. Talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear.